Good morning. Computer Science 221. In our last video, we developed the D latch, or the D flip-flop, and we said that that was the basic unit of storage. And remember, we had this thing. We'll draw it a little differently now. We'll draw it as a box. And we'll say there's input here. That's going into D. There's something over here that's called write enable. And there's output here. There's a line that's coming in here. And actually, what I want to do is I want to draw a few of these. And let's suppose we have 4 separate lines coming in. I'm going to give these lines numbers. I'm going to call this input 0. I'm going to call this input 1. Input 2, input 3. We've got 4 lines coming out. We'll call that O3, O2, O1, O0. And I'm going to take this write enable line. I'm going to have it go into all of these guys right over here. So what we really have over here is this is an example of what's called a 4-bit register. And the way to think about this, again, we have these 4 lines coming in, these 4 lines coming out. We can imagine that we put some values on here. So maybe I'm going to put a 1 and a 0 and a 1 and a 1. Now, as long as there is a 0 on the write enable, that is not going to change the contents of any of these things in here. Okay, so there will be some numbers coming out of here. I don't know what they are, but they're whatever the currently stored values are in these things. But if I come over here and I put a 1 here on write enable, now what's going on is now this is going to assume the state of 1. This would have the state 0. This would have the state 1. And this would have the state 1. Just like that. And if I came back here now and I were to change this to a 0, okay, now what would happen is over here, O3 would get the value 1, O2 would get the value 0, O1 would have the value 1, and O0 would have the value 1. So again, this is a 4-bit register. The other thing that I want you to note here are these lines coming in and these lines going out. That's sometimes what's referred to as the bus. And we're going to encounter that word a lot more as this video continues. Might be a little bit cliche, but you might consider the bus the information highway. Okay, so we have a bus that is 4 bits wide. You'll hear people talk about that. Back in the 1980s, the original PCs and Apples had an 8-bit bus. Computers today have a 64-bit bus. And you should recognize that the wider the bus or the bigger the bus, what that means is that you're moving more information around at once, which means that you can do more at once. Okay, so where we're going to go from here is we want to talk about memory now. Okay, the structure of memory. And people might be wondering, are we talking about RAM? Are we talking about ROM? And the answer to that is that it really doesn't matter, but if it makes people feel better, you could think of this as being RAM memory. Remember, RAM is random access memory. And very frequently, when people talk about memory, people think about a big array. They think of something that looks like this. And in a modern day computer, each one of these slices here is numbered 0, 1, 2, and it goes up to some very big number. For example, on a computer today, it might go up to 16 billion, 16,000, million, billion. Okay? And then the other thing is if we were to take one of these slices out of here, we know that we can break that up into bits, that there are individual bits that are stored in here. Whatever. Okay, so there are two dimensions that people talk about when they're talking about memory. First of all, they talk about the address space. And then they also talk about the addressability. And the address space, you could think of that as how many slots are there. And you could think of the addressability as being how wide is each slot. Okay, so you could think of this distance from here to here you could think of that as the addressability. And you could think of this here as the address space. So what we're going to do now, and this is actually right in your book, and it's a pretty complicated picture in the book, and I'm going to try and make it simple. I'm not sure if my artistry is going to succeed or not, but in your book they devise a 2 to the squared by 3 memory. And what's going on over here is the 2 squared, this is the address space. And the 3 over here is the addressability. Okay, so let's do that. So there are a couple of preliminary things that we need to do here. So first of all, we're going to have a bunch of D flip-flops. So each one of these are Ds. Okay, and notice that there are 3 columns, there are 4 rows. Now, if we want to, we could think of this as being memory location 0. This is memory location 1. This is memory location 2. This is memory location 3. Okay, and up here, we can imagine that there are 3 input lines. And again, this is our bus. So here is input 0. Here is input 1, here is input 2. Now over here, got a bunch of things going on. First of all, there's a line coming down here, and this is my right enable line. And over here, I'm going to have some select lines, and I'm going to use the notation that your author uses. There are two lines here. And they come down like this. And the basic idea, what I'm doing with these two select lines, this is going to be a decoder. And actually what I'm going to do is I'm going to build a 2x4 decoder. And remember what that's doing. I have 2 bits as input, and they act as a binary number. And what they do is they turn one of these 4 lines high. So you may recall that the way to do this, I'm going to come over here, and I am going to have an AND gate here where I'm going to invert both signals. And here's my output. So that when there's a 0, 0 on this line, both of these zeros get inverted. So I have a 1 and a 1, and a 1 would come out there. I'm going to come over here, and I'm going to invert this line, but not this one. So again, when there is a 0, 1 on here, that's going to put a 1 on here, and this 0 will get inverted to a 1, and there would be a 1 that comes out. Over here, I'm going to have another AND gate. And this time, I'm going to invert that line. So when I put a 1, 0 on here, this one will go high. And over here, I'm not going to invert any of the lines. So what happens over here is that if I put a 1, 1 on here, there's going to be a 1 that comes out of there. Note that if I put a 1, 1 on these lines here, the output here would be 0, 0, 0, and a 1. And now what I'm going to do is I'm going to come over here to this right enable. And I'm going to come over here, the output of this decoder, and I'm going to feed this into an AND gate and stick that into the right enable. There. And I'm going to come over here and do the same thing over here. Already this drawing is not looking good. I'm going to have another AND gate here. And I am going to do the same thing over here. So here's the thing to notice here. If I were to put 0, 0 on this line, there's going to be a 1 coming out of here. And if right enable is 1, there's a 1 coming out of here, there's a 1 going here. I have just set the right enable line high to this flip-flop. On the other hand, if there's a 0, 0 on this line here, the output of all of these is 0, and there would be a 0 going into the right enable line. So what I'm going to do is I'm also going to take this line right here. I'm going to tie it into the right enable pin on that flip-flop. I'm going to tie it into the right enable on that flip-flop. So that when there is a 0, 0 on the line and right enable is 1, I've enabled these 3 D latches here. And what I'm going to do, obviously, is come over here and let that be the input there, let that be the input there, and let that be the input there. And I think you can see what we're going to do all on these other ones here. I'm going to come over here, input, 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 like that. And what I'm going to do over here is take this line down to there, down to there, and down to there. Okay, so let's look at this picture here now. Let's suppose there is a 1, a 0, and a 1 over here. And let's suppose over here on this line here, let's suppose I put a 1 and a 0. And let's suppose I put a 1 here. Now first of all, if I put a 1 and a 0 on here, the output here is 0. So this right enable is going to be 0. If I put a 1 and a 0 in here, okay, what is going to happen is there is still going to be a 0 coming out here, so this right enable is 0. But if I put a 1 and a 0 here, the output of this is a 1. Now there's a 1 on the right enable line, so what's coming out of this AND gate here, this very ugly AND gate, is there's a 1 going into this right enable, there's a 1 going into this right enable, and there's a 1 going into this right enable. So what I've done is I've right enabled this whole row. And what's going to go into here? Well, I'm going to load this up with whatever I2 has. So there's going to be a 1 that goes in there. And what's going to come down in here is there'll be a 0 in here. And what's going to happen is they'll come down and there'll be a 1 in here. The other 3 rows are unchanged. This one got changed. Okay? Is everybody all right with that? So this is the input picture. Okay, for the output picture, and I'm going to see if I can do it on this particular one. I think I can. I'm going to come over here. Okay, so basically what I have to do for the output is I'm going to need a mux. And I want you to watch the way that I do this. I'm going to come over here and do it. Now remember, each one of these flip-flops has an output. And I'm going to come over here and I'm going to call this the output. Right there. I'm going to come down here. And I'm going to come over here, and I'm also going to take the output of this decoder here. And I'm going to try and draw this as cleanly as I can. And I'm going to put that into an AND gate, right there. And I'm going to do the same thing over here. So here is the output of this. And I'm going to come over here, and again, here's the output of my decoder here. And I'm going to stick that into an AND gate. And now, if you don't mind, I'm going to do a little erasing. Because I need a little space over here. And I'm going to come over here, and I'm going to take the output of this decoder line. I'm going to come way over here. And I'll take the output of this flip-flop, and I'm going to put that into an AND gate. And then likewise, I'm going to come over here and take the output of this decoder line. I apologize, I got really messy there. And I'm going to take the output of this flip-flop, and I'm going to put that into an AND gate as well. We're almost done. And now what I need to do is I've got this line coming down. I've got this line coming down. I'm going to put it right next to it. I've got this line coming down. And I've got this line coming down. And I'm going to put this into an OR gate. And draw a line here. And if this was input 0, I'm going to call this output 0. And likewise, what's going to happen over here, I'm not going to draw them all. Again, you can look in your book, but I'm going to have an OR gate over here. And they're going to be 4 lines coming in. And those 4 lines are going to be coming from, I'm going to be ANDing the decoding line here with the output of these various flip-flops, and this would be O1. And over here there would be one more OR gate, with 4 lines, and that would be O2. So again, let's follow this one through. Suppose now that this has a 0 in it, and let us suppose that there was a 1, 1, 0 here. Now there's a 0 here, and there is a 0, 0 here. Now first of all, if there's a 0 on the right enable, remember the input to all of the right enables on all of these chips is 0, and nothing is getting changed. But now if I have, let's change this to 0, 0. Now if I have a 0, 0 here, 0, 0 going into this AND gate makes the output of this AND gate a 1. So I'm going to follow this line all the way over here. And notice over here I have a 1 going into this AND gate, and I have the output of this. So I'm putting a 1 and a 0 into this AND gate. A 1 and a 0 into this AND gate means I'm going to be outputting a 0 here. Now all of these other ones, okay, what's going on is this decoder line, and this decoder line, those are all 0, which means that I have zeros going into these AND gates. The output of these are all going to be zeros. And when I OR all zeros together, the output here is going to be 0. Now, here's where it gets interesting, this one over here. Because what's going to be happening here, remember there is an AND gate over here. I haven't drawn it, but we could. I could draw it right there. And the input to that AND gate is from this decoder line and from this chip right over here. Right like that. And this, of course, comes down and goes right into that line there. So what happens here is there's a 1 on the decoder line. There's a 1 coming in here, so there's a 1 coming down here. These other 3 lines are all going to be 0 because the decoder lines are all 0, and those are inputs to the corresponding AND gates here. So that's how we get the output. So the whole thing to remember here is that we are using a decoder to select the lines for input, and we're actually using the decoder as part of the circuitry for a MUX to get us the output lines. I think that this is pretty explanatory. If not, you should take a look in the book where I can promise you the picture is a lot cleaner.